Welcome to Institute of Quality and Reliability. Hi, this is Hemant. System Reliability Quiz and Case Study. Please watch our following videos on the subjects of Weibull distribution and reliability block diagrams before watching this video. Links are provided in the description of this video. System Reliability Quiz and Case Study for the viewers. A company makes engines for automobile industry. The engines are brought for first overhaul to the company service center when a durability failure is reported for any of the following 6 types. The failure modes are 1. Bearing failure, 2. Camshaft failure, 3. Crankshaft failure, 4. Gear failure, 5. Cylinder head failure, and 6. Power cylinder failure. The company has analyzed data for these 6 failure modes that require engine overhaul. Live data analysis summary with graphs is shown on the next pages. Based on the values of the Weibull parameters, find out the system reliability and B10 life. Assume that any of the 6 failure modes can result in need to overhaul the engines. Here is the live data analysis for the first 4 failure modes, namely bearings, camshafts, crankshafts and gears. Observe and note down the Weibull distribution parameters. And this is the analysis for the remaining 2 failure modes, that is cylinder head and power cylinder PC. Instructions for the exercise are as follows. Study the above analysis for the distribution and parameters carefully for each component and failure mode. Create an Excel sheet with scale and shape parameters in the top row. Estimate reliability of each component from 5000 to 40,000 hours at interval of 5000 hours or as may be appropriate using the above parameters. Estimate system reliability or durability for these hours assuming that system will need overhaul if any of the above 6 components fail. Now try creating an Excel sheet as per the previous instructions and calculate durability of each component at the various time intervals created. Then calculate the system durability at these intervals. Assume that occurrence of each failure mode is independent and will require overhaul of the engine. Please pause the video now and then try the exercise on Microsoft Excel. Are you done? Now watch the suggested solution in the next part of this video. Hello friends. In the problem statement, it has been mentioned that there are 6 failure modes and a live data analysis or Weibull analysis of all these 6 failure modes has been given. The same is summarized in this worksheet as shown on the right side. Based on this information, let us create a worksheet as shown here. As there are 6 failure modes from bearing to power cylinder, we reproduce the scale and shape parameters of all the 6 failure modes in the top row. And on the left side column, in the time in hours, we create time values of 5000, 10,000 and so on up to 40,000. We can add any interim values if required. So please create a worksheet like this. Once you create this worksheet, let us now use the Weibull distribution formula to estimate reliability of each of the failure mode at each of the time. Remember that as per the Weibull distribution, reliability at time t is given by e to the power minus t upon eta, that is the scale parameter, raised to the power beta. In each case, we have been given scale parameter in the top row of this. So this is the eta parameter, and on the lower row we have the shape parameter, which is the beta parameter. Using these parameters and the time in hours, we can create Weibull equation for each of the cell. So let us create it for the first cell, that is at 5000 hours, for the first failure mode bearing. So we use the equal to symbol to create a function here. Before copying this formula, we need to also add dollar symbol for the column of time, because we want to use the same column when we copy. So we put $A6 or whatever cell you have. And when we copy this now, we should get reliability of all the 6 failure modes, and then we copy vertically for up to 40,000. So we have estimated the reliability or durability for all the failure modes from 5000 to 40,000 hours. Now the system reliability is just a multiplication of all, because they are in series, because if any of the failure mode occurs, the system requires a complete overhaul. So we multiply reliability of each cell or for each failure mode to estimate the system reliability. It is multiplication of all 6 failure modes, and the probability of failure is just 1 minus the system reliability. So we can copy this for all the, so we can see that the system reliability and probability of failure is tabulated in this, and we can clearly see that the system reliability drops from 0.9904 to a very small value, 6.99 into 10 raised to minus 5, that is nearly 0 at 40,000 hours. And probability of failure obviously increases from 0.00958 to 0.9999, etc. We will reduce the decimals for the sake of convenience of seeing the values. So we will do it up to 5 decimals. We can also plot a graph of system reliability. So for that we can easily select time and then control button and system reliability, and we'll say insert recommended charts, and we can see the system reliability graph like this. So we can see how the reliability is dropping. We have also been asked to find out what is the B10 life. So that corresponds to reliability of 90%. As we can see in the system reliability graph, and also from the table of course, that at 10,000 hours the system reliability is 0.91, and at 15,000 it drops to 0.70. So obviously the beaten life is between these two, so it's probably likely to be closer to 10,000. So we can add few rows here, and after adding few interim values, we can find that the beaten life is approximately at 10,400 hours. Thanks for watching this video. Hope you found it worth watching. Please subscribe to Institute of Quality and Reliability channel if you want to watch more videos on reliability engineering, Six Sigma and quality engineering.